Example number 1, evaluate the limit x tends to 0 e raised to x plus e raised to minus x minus 2 divided by 1 minus cos x. Now here if you put x is equal to 0, then as we know that e raised to 0 is 1, so it is 1 plus 1 minus 2 divided by 1 minus 1, so it is 0 by 0 form, and therefore if limit x tends to 0, f of x divided by g of x is of the form 0 by 0 form, then this is same as limit x tends to 0 f dash x divided by g dash x. Okay, this is called L'Hospital rule. So by using L'Hospital rule, this limit is equal to limit x tends to 0 e raised to x plus e raised to minus x minus 2 divided by 1 minus cos x is equal to limit x tends to 0, the derivative of e raised to x is e raised to x, and derivative of e raised to minus x is e raised to minus x divided by 1 plus derivative of cos x is equal to sin x. Now again if you put here x is equal to 0, then this is equal to again 1 minus 1, that is 0, and 1 what is here x, if we take x is equal to derivative of 1 is 0, so it is, if we take sin 0 is equal to again 0, so this is 0 by 0 form, and therefore again by using LH, again if we apply L'Hospital rule, then this is equal to, again differentiate function, so limit x tends to 0 e raised to x minus e raised to minus x divided by sin x is equal to limit x tends to 0, derivative of e raised to x is e raised to x, derivative of e raised to minus x is e raised to minus x, again derivative of minus x is minus 1, so minus minus become plus, and derivative of sin x is cos x. So now if you put x is equal to 0, then it is 1 plus 1 divided by cos 0 is 1, so the answer is 2. So the limit is equal to, what is your answer? Answer is equal to 2. You can use a maxima also to find a limit of the given function. How to find a limit in the maxima? Suppose our f of x is equal to say exp of x, and we want to determine a limit of f of x in the variable x, and the limit is 0, that is equal to 1. But our given function is e raised to x plus exp of minus x, then minus 2, okay, sorry, minus 2, this whole divided by, now first if you want to check the numerator limit, then this is equal to, the limit of numerator is equal to what? 0. Again it is divided by, suppose if we take here g of x is equal to say if you write here g of x is equal to what is the function is given, 1 minus cos of x, and if you write here limit of g of x in the variable of x and limiting point is 0, then it is equal to 0. So you can find the derivative of limit of numerator and denominator separately, and you get 0 by 0 form. Now if you try to evaluate limit f of x divided by g of x with in the variable x, limiting point is 0, the limit is what? Limit is 2. What is f of x upon g of x? It is e raised to x plus e raised to minus x minus 2 divided by 1 minus cos x. So here limit is 2. Now next example number 2. evaluate the limit x tends to 0, x tends to infinity, x raised to 1 by x. Now this is infinity raised to 0 form. Why? Because since 1 by infinity is 0, 1 by infinity is 0. So now to evaluate this limit, we assume here the value of this limit is L. So limit x tends to infinity, x raised to 1 by x is equal to L. Now if you apply log on both sides, log L is equal to limit x tends to infinity log x divided by x. So now if you put infinity here, this is what log infinity is infinity and x is infinity, so it is infinity by infinity form. So by L hospital rule, this is equal to log L is equal to limit x tends to infinity, the derivative of log x is 1 by x and derivative of x is 1, and limit x tends to infinity, 1 by x is nothing but the 0. So log L is equal to 0 implies L is equal to e raised to 0, which is equal to 1, and therefore limit is equal to what? 1. Now next example number example number 2, limit x tends to pi by 2, to sec x minus tan x. Now as sec pi by 2 is infinity and tan pi by 2 is also infinity, so this is infinity minus infinity form. We want to convert this indeterminate form either 0 by 0 or infinity by infinity, as we know that sec x is equal to 1 divided by cos x and tan x is equal to sin x divided by cos x. As a denominator is same, we can add a numerator. So this is limit x tends to pi by 2, 1 minus sin x divided by cos x, and now sin pi by 2 is 1, so 1 minus 1 is 0, cos pi by 2 is 0, so this is 0 by 0 form, and therefore by using L hospital rule, this is equal to limit x tends to pi by 2, the derivative of 1 is 0 and derivative of sin x is minus cos x divided by the derivative of cos x is minus sin x. Okay, and now if you put here cos pi by 2 is what? Cos pi by 2 divided by sin pi by 2, as sin pi by 2 is 1, cos pi by 2 is 0, so it is 0 by 1 is equal to 0, and therefore the value of this limit is equal to 0. You can use a maxima also. So here in maxima, if you write f of x is equal to, say f of x is equal to sec of x minus tan of x, cannot assign to f of x is equal to sign is missing. So, and if you write here limit, okay, limit f of x, the variable is x and the limiting point is pi. So to enter pi, we write percentage sign by 2, and you can check the limit is what? 0 here. Limit is what? 0. To enter symbolic constant, we write a percentage here, percentage sign. Okay, so the answer is what? 0. And the second question is what? Limit x tends to infinity, x raised to 1 by x. So if we take again f of x is equal to x raised to 1 by x, and what is here? If we write a limit of f of x in the variable x and the limiting point is infinity, then answer is what? 1. Answer is what? 1. You can check here, our answer is what? 1. Here limit is what? 1, and here limit is what? 0. Now the next example number 3, find the Taylor series of cos x, that is f of x is equal to cos x. Find a Taylor series at x is equal to 0, at x is equal to what, 0. So now the formula for f of x is equal to f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0 plus x cube by 3 factorial x triple dash 0 and so on. So here f of x is equal to cos x implies f of 0 is equal to 1. F dash x is equal to minus sin x and f dash 0 is equal to 0. Then f double dash x is equal to minus cos x and f double dash 0 is equal to minus 1. F triple dash x is equal to sin x and f triple dash 0 is equal to 0. Fourth derivative at x is equal to cos x and fourth derivative at 0 is equal to 1. So if you substitute all these value here, that is f of 0 is 1, f dash 0 is 0, f double dash 0 is 1, f triple dash 0, fourth derivative again 1. I think it is minus 1, not 1, it is minus 1. Okay, so if you substitute this value, we get cos x is equal, what is f of x? Cos x is equal to f of 0 is 1 minus f dash 0 is 0 plus x square by 2 factorial f double dash 0 is minus 1, again 0. Fourth derivative is x raised to 4 divided by 4 factorial into 1 and so on. So if you simplify this, we get cos x is equal to 1 plus x square by 2 factorial minus x raised to x raised to 4, here not plus, I am writing once again. So what is cos x here? Cos x is equal to 1 minus x square by 2 factorial plus x raised to 4 divided by 4 factorial. Next term will be x raised to 6 divided by 6 factorial. Next term is x raised to 8 divided by 8 factorial and so on. So this is the Taylor series expansion of cos x at x is equal to what? 0. Similarly, you want to determine the Taylor series expansion of f of x is equal to 1 divided by the next example, f of x is equal to square root of 1 plus x and the expansion is given at x is equal to 0 again. So what is your f of 0? F of 0 is 1. What is f dash x? F dash x is 1 divided by square root of 1 plus x and therefore f dash 0 is equal to 1 by 2. F double dash x is equal to, okay, now what is as we know that the derivative of 1 upon x raised to n is minus n divided by x raised to n plus 1. So here the power is what? This is nothing but the 1 by 2, 1 divided by 1 plus x raised to 1 by 2. So we want to write here 1 by 2 into minus 1 by 2 divided by 1 plus x. We want to increase the power by 1. So 1 by 2 plus 1, it is 3 by 2. So this 1 by 2 get cancelled here and f double dash 0 is equal to minus 1. Similarly, f triple dash 0 is equal to minus it is 3 by 2 divided by 1 plus x raised to 5 by 2. It is what? 3 by 2 plus 1, 5 by 2. So f triple dash 0 is equal to 3 by 2. So similarly, if you find next derivative, fourth derivative of x, it is equal to, this is fourth derivative of x, 3 by 2 into 5 by 2, it is 15 by 4 and 1 plus x raised to 5 by 2 plus 1, it is 7 by 2. So fourth derivative at 0 is equal to 15 by 4. So now if you substitute all these values, okay, in the given equation, then we get, okay, it is equal to f of x. What is the expansion here? F of x is equal to I'm writing f of x is equal to f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0 plus x cube by 3 factorial f triple dash 0 plus dot dot dot. So what is f of x here? Square root of 1 plus x. So f of 0 is 1. What is f dash 0? F dash 0 is equal to 1 by 2. So it is 1 by 2 x. So it is x square by 2 factorial into f double dash 0. So what is f double dash 0? F double dash 0 is equal to minus 1. So this is equal to minus 1. Something went wrong here. Okay. So this is not 1 by 2, 1 by 2 not get cancelled here. It is what? Something went wrong. 1 by 2, 1 by 2, it is minus 1 by 4. Minus 1 by 4. And so it is, this is what? Minus. If you want to multiply here, minus 1 by 4. So this is equal to minus 3 by 8. And here if we multiply minus 1 by 4, we get minus 15 by 16. Okay, and so here it is minus 1 by 4, not minus 1 by 4, plus x cube by 3 factorial. What is f triple dash 0? F triple dash 0 is nothing but the minus 3 by 8. Minus 3 by 8. So if you simplify this and so on, simplify this, it is 1 plus x by 2 factorial, so it is x square by 8, 3 factorial is 6, so it is minus x cube by 16. Okay, and so on. So this is what the Maclaurin series or Taylor series expansion at x is equal to 0 of square root of 1 plus x. Now the next example is, so the next example number, say next example maybe 4 or 5. Find nth derivative of x divided by x minus 1, x minus 2. As if f of x is equal to 1 divided by x plus b, then f dash x is equal to fn x is equal to, it is a raised to n, it is a raised to n factorial minus 1 raised to n divided by ax plus b raised to n plus 1. So the first we want to resolve this function f of x is equal to x divided by x minus 1 into x minus 2 into partial fraction, x minus 2 into partial fraction. So it is a divided by x minus 1 plus b divided by x minus 2. So this is equal to x divided by x minus 1, x minus 2 is equal to a into x minus 2 plus b into x minus 1 divided by x minus 1, x minus 2. So this will get cancelled here. So it is x is equal to a times x minus 2 plus b times x minus 1. So now if we put x is equal to 1, then 1 is equal to minus a. So this implies a is equal to minus 1. A is equal to minus 1. And if x is equal to 2, then b is equal to 2 is equal to b. So this implies b is equal to 2. So x divided by x minus 1, x minus 2 is equal to a divided by x minus 1. So a is what? Minus 1. Minus 1 divided by x minus 1, and next 2 divided by x minus 2. So the nth derivative of this function is, now as we know that 1 divided by ax plus b then its nth derivative is minus 1 raised to n factorial a raised to n divided by ax plus b raised to n plus 1. So if you compare this with 1 divided by x minus 1, then here a is equal to 1 and b is equal to minus 1. So this is equal to its nth derivative is minus 1 raised to n factorial divided by x minus 1 raised to n plus 1. Okay, but there is a minus sign, one more minus sign, because it is minus 1 into x minus 1. So here we want to increase it by plus 1. So if you multiply by minus sign, and 2 divided by x minus 2, again here a is 1, okay, b is minus 2, so this is minus 1 raised to n factorial divided by x minus 2 raised to n plus 1. So now it is x divided by, so the nth derivative of the function x divided by x minus 1, x minus 2, its nth derivative is equal to minus 1 raised to n plus 1 n factorial divided by x minus 1 raised to n plus 1, then plus what is here, nth derivative of second term is 2 minus 1 raised to n factorial divided by x minus 2 raised to n plus 1. If you simplify it further, that is, if you take minus 1 raised to n outside, minus 1 raised to n outside, n factorial is outside, then inside the bracket it is 2 divided by x minus 2 raised to n plus 1, and minus of, we interchange the term here, minus of 1 divided by x minus 1 raised to n plus 1. So this is what the nth derivative of the given function. The next example is prove that if y equal to sine inverse x. The next example number 5, if y is equal to sine inverse x raised to 2, then prove that 1 minus x square raised yn plus 2, then minus twice n plus 1 x yn plus 1 minus n square yn equal to 0. So now here we are going to use the Leibniz rule, and here we want to prove yn plus 2. So we want the term y2 first, and then we are going to take a nth derivative. So if y is equal to y1, then yn is equal to yn plus 1 first of all, and if y is equal to y2, then yn is equal to yn plus 2. Remember this thing. So to get yn plus 2, we must want to take a derivative of y up to second derivative, we want to differentiate y up to or 2 times. So if first we differentiate with respect to first time, then y1 is equal to, instead of writing y dash, I am writing here y1 is equal to 2 times sine inverse x, and derivative of sine inverse x is 1 divided by 1 minus x square. So now if we multiply this 1 minus x square to this side, we get 1 minus x square. If we multiply this term to this side, okay, then y1 is equal to 2 sine inverse x. Here is a square root term. Now to remove square root sign, we are going to square on both sides. If you square on both sides, we get 1 minus x square y1 square is equal to 2 times sine inverse x bracket square. But what is sine inverse x square? Sine inverse x square is equal to what? Y. So this is nothing but 1 minus x square y1 square equal to 2y. So again, if you differentiate this one more times, we get 1 minus x square, and derivative of y1 square is 2y1, and again derivative of y1 is y2, plus y1 square into derivative of 1 minus x square is minus twice x is equal to 2y1. So this is equal to, if you take this y1 outside, 2y1 outside, then we get 1 minus x square y2. If we take y1 out square, 2y1 out square, then minus xy1 and minus 1 is equal to 0. Now if 2y1 is equal to 0, 2i1 2i1 is not equal to 0, implies 1 minus x square y2 minus xy1 is minus 1 equal to 0. Now say this is equation number 1. Now we are going to differentiate, take a nth derivative of these two terms separately. First we are going to take a nth derivative of this xy1. As we know that if y is equal to uv, then yn is equal to nc0 u raised to n v0 plus nc1 u raised to un minus 1 v1 and so on. So here for xy1 we select u is equal to x and v is equal to y1, then u dash is equal to u is equal to we are going to select here, okay. We want to take here, okay. So for xy1 we select u is equal to y1 and v is equal to x. So here un is equal to yn plus 1 and v dash is equal to 1 and v double dash is equal to what? 0. So we want this formula up to only v1, that is v, not v dash, it is v1. So the for formula up to v1 is equal to, say yn is equal to nc0 capital Yn, here say capital Yn, nc0 un v0 plus nc1 un minus 1 v1, okay. So if you substitute this value, nc0 is equal to 1 and un is equal to yn plus 1, so it is yn plus 1 v0 is, this is v0 which is equal to what? X plus nc1 is n un minus 1. What is ncr formula here? ncr equal to n factorial upon r factorial n minus r factorial, and therefore nc1 is equal to n factorial upon 1 factorial n minus 1 factorial. So this is nothing but the n. So un minus 1 is yn and v1 is equal to 1. So this is the x y1, its nth derivative. Okay, similarly now we want to determine nth derivative of 1 minus x square y2. So the nth derivative of, for 1 minus x square y2 we select u is equal to y2 and v is equal to v0 equal to 1 minus x square. So un is equal to yn plus 2 and v1 is equal to minus twice x and v2 is equal to minus 2, and if you differentiate v3 v4 they are all equal to what? 0. So we want to write a formula up to nc0 un v0 plus nc1 un minus 1 v1 plus nc2 un minus 2 v2, okay. So what is nc0? It is 1. Un is equal to yn plus 2 v0 is equal to 1 minus x square plus nc1 is n un minus 1 is yn plus 1 v1 is equal to minus twice x, nc2 is n factorial divided by n minus 2 factorial, so it is equal to n minus 1 divided by 2 factorial, it is 2 factorial is 2 into un minus 2 is yn and v2 is what? Minus 2. So if you simplify this, it is equal to 1 minus x square yn plus 2 plus sorry, not minus twice x, sorry, minus twice x n yn plus 1. This 2 will get cancelled here, it is minus n minus 1 yn. So this is what nth derivative of 1 minus x square y2. This is what nth derivative of this function. So now say this equation number 2, if you from 1 and 2, what is 1? xyn, xy1, its nth derivative is equal to xyn plus 1 plus nyn. So if you subtract these two equations, we get, since what we want the solution for this equation 1, the nth derivative of 1 is 0, the nth derivative of this term is what? Is 0. And nth derivative, we have determined the nth derivative of these two functions. So if you subtract these two functions, we get 1 minus x square yn plus 2. Okay, now we want yn plus 1 term in one bracket. So here is the first term, a minus sign, but minus minus minus. So it is what? Minus twice xn minus x, okay, yn plus 1. Then next minus n square minus n, okay, minus n yn equal to 0. So if you simplify this, it is 1 minus x square yn plus 2. If we take minus n outside, it is twice n plus 1 xyn plus 1, okay, plus 1. And last it is what is this? Minus n, sorry, minus n, and because of this minus sign, this minus minus become plus here. So this s n get cancelled here. N square yn is equal to 0. So this is what we want to prove here. Okay, thank you.